planet Earth. In 4,500 million years, our world has gone through many natural changes. Now it's changing once again, but this time we ourselves are contributing to those changes. We are causing the world to heat up. If we continue to behave as we are doing, our children and grandchildren will have to deal with extreme and potentially catastrophic changes. The vast forests of the Amazon could wither and burn. The oceans could turn acid, destroying much of the life they presently contain. The Arctic could be transformed, its ice could melt, and its most famous animals vanish forever. Rising tides could cast millions of people adrift. Many of our coastal cities could be flooded and drowned. We still have time. There are ways to minimize these changes if we all choose now to adopt them. But the next few years will be crucial. If we miss our chance, the future may be grim indeed for life on planet Earth. The great majority of scientists are now agreed that our planet is warming and that human beings are at least some part of the reason it's doing so. The questions now are what is going to happen and what can we do about it? We know there is now more carbon dioxide in the atmosphere than at any time in the last 650,000 years. Carbon dioxide is a greenhouse gas. Invisible and odorless, it surrounds our planet, warming it like a blanket. And every year we add another 25 billion tons of it to the atmosphere. As the blanket gets thicker, the planet gets warmer.
That was the forecast for 2006, and this may well be the forecast in 2050. Yes, you're not hearing things 44 years from now, and it will probably be another scorcher. Now, temperatures in the early 21st century were record-breaking at 38 in London and 33 across Scotland, more par for the course nowadays, and quite a sultry night to come for many, with temperatures just outside London no lower than 26 degrees Celsius. And it's going to be followed by a scorcher of a day tomorrow. Again, the dry weather, the heat continues, so no relief from the drought in the southeast of England. Not great news for the gardeners. These longer growing seasons are not being matched by increased summer rainfall, unfortunately. The Midlands still dry.
Most of us relish the chance to soak up a little heat. Remember the summer of 2003? But that summer had a dark side. Tens of thousands of Europeans died in the heat. While summers like that are still rare, the odds are that by the middle of this century we'll get such a scorcher every other year. And by the end of the century, it will be so hot that a summer like 2003 will feel cold. That sounds frightening. Is it really true? We all would like to know for certain what will happen to our climate in the future, whether we'll be sweltering in a heat wave or inundated by floods. But scientists can only give us a range of possibilities, and what they're telling us is that our world will warm anywhere between 1.4 and 5.8 degrees Celsius in the next century. To put it another way, the impact of global warming will be somewhere between severe and catastrophic. Weather predictions of any kind are not easy, but at the Met Office's Hadley Centre, the forecasters have a particularly difficult problem.
Clear sky and cloud.
They're looking at what our climate might be like in 100 years from now, using a process called climate modelling.
I mean, what are we talking about, 4 degrees in places? Climate models essentially have come out of weather forecasting models. What they really do is they lay out a series of options based on what we do about climate change. And it's up to us, it's up to humankind to decide which of those paths to follow.
The modellers use one of the most powerful supercomputers in Europe, crunching 10 billion calculations every second. It's like a flight simulator for the future climate. They can ask it questions like, what happens if we double our carbon dioxide emissions? Or how hot will it get? Overall, it looks as if we're in for a bumpy ride.
There are many climate models across the world now. They all, for example, agree that greenhouse gases are going to warm up the system, and by similar amounts. No models are saying no climate change. They're all saying actually somewhere between 2 degrees and maybe 6 degrees. Even 2 degrees, in many people's eyes, is a dangerous climate change. Six-degree warming over 100 years would be such a rapid warming that it would be very difficult to see how that wouldn't damage things irreparably.
To help me visualize what is in store for us, Peter Cox invited me to see a film. This is a vision of how and where the world will heat up if we continue down the path we're now on. This prediction suggests that by the year 2100, the south of England will have an average temperature lift of 2 degrees.
Yeah.
Most people would think, well, that wouldn't be too bad. I mean, maybe the south of France has come to southern England.
Well, it will be warmer, there's no doubt it'll be warmer, but there are obviously many aspects to climate change. In southern England particularly, we're concerned that we'll have drought conditions, so summers will get quite a lot hotter and drier. And again, people might think that was fine. But also we expect changes in the extreme events, more stormy conditions, more flood conditions. There's a lot more to the problem than just the warming.
It has been much drier in recent summers, but when we do see the rainfall, it's very intense. And again, just about anywhere during the day could have some localised flash flooding from those torrential thunderstorms. And it's going to be a pretty sultry day in Scotland as well.
The Met Office believes that in the future, when it does rain, it will pour. Some places in Britain, especially in winter, are forecast to be 5 times more likely to flood.
Devastating flash floods in North Cornwall which demolished homes and left scores.
A month's rain fell in less than 2 hours.
When the floodwaters swept through the old part of the village by the harbour without mercy.
I've been utterly shocked at the devastation below me. I'm looking down.
Sergeant Shuey Thompson of the Royal Air Force was among the rescue teams who saved 100 people during the 2004 Boscastle flood.
I must admit, my first impression was how many people are going to survive this.
As our climate changes, extreme events like Boscastle are more likely, and emergency services are already preparing for them.
Climate change is something that we're going to have to deal with. We are seeing a change in the weather. So we do need to prepare for the fact that there may be more flash floods and other dangerous situations and be prepared really to continue rescuing people maybe in a more dramatic situation in the future. And it's not just Boscastle, there's other valleys around with big tributaries that are running into them, and so this could really happen anywhere at any time.
We have always built our houses and roads with the weather in mind, but the continued effectiveness of our structures is something we can no longer take for granted. This sea wall in Essex was built to protect the houses behind it from high tides and storm surges, and it's worked very well. But the climate is changing, and there is no guarantee that it will give that protection in the future. The houses that stand behind that wall, like millions of homes all over the world, are perilously close to sea level. There are many such all along the Gulf Coast of America. Here, hurricanes occur every year. In August 2005, many citizens of New Orleans thought Katrina was just another. They felt secure behind levees that had been built, extended and heightened since the 18th century.
A little bit panicked this time?
Oh, no, I'm okay. But yeah, it feels a little bit more dangerous than a blizzard, so we'll be okay.
But Katrina caused the storm surge higher than the Asian tsunami. 4 of New Orleans' levees broke, flooding 80% of the city and killing over 1,000 people.
Man, how do you get a house in that sort of a position?
Hurricane expert Greg Holland thinks we need to be fortifying our defences and preparing for the future now.
So this is where the industrial canal obviously broke. And you just have to imagine a huge wall of water rushing all the way down through here, taking out everything. I mean, there is nothing left. Anyone in this area was either dead or in extremely bad shape. Imagine the sort of crash you'd have to have on a highway to actually do this sort of damage. Incredible. The worrying thing is that all the damage we see here was due to Hurricane Katrina, which wasn't a particularly powerful hurricane. Think of the potential future destruction with the much more powerful hurricanes that are likely to occur with climate change. The damage that we see around us here tells me that the future is here and we really do need to take appropriate action now.
On the other side of the world, many Australians are also going to have to find new ways of fighting an old enemy. Here, it isn't rising seas, it's fire.
Our concern about climate change is that something appears to be happening. We're not sure what it is. Bushfires are part of the Australian phenomenon. They've been around for millions of years. What's changing is the weather conditions and the volatility of the weather that's causing us real concern about how the fires behave, the frequency of the fires.
Russell Rees has spent the past 30 years firefighting in Victoria, but after the hottest year on record, he realises that in future he'll need a new approach.
We've built fire services traditionally around a belief and a well-honed theory about how fires behave. Fires become harder to control, they become more unpredictable. Our normal methods of measuring fire behaviour are being put into question. If things are changing, then we have to rethink that. We have to rethink our resources, our tactics, our strategy, the whole way we go about it, so that we can defend and protect in this sort of change.
In the future, there is even a chance that Britain could have its share of forest fires.
I should imagine by the time we get to the middle of the century, there will be a significant risk, increased risk that is, of grass and forest fires, just because things are so bone dry following the dry weather and the heat, and there's no sign of that letting up either. And talking about heat and potential forest fires as well, let's head to Europe.
How reliable is this particular projection?
It depends on where you look. I think if you look over the next few decades, most models would agree on the warming that we're likely to see. We don't have very much choice over what happens over the next 25 years because that's largely a function of what we've emitted in the past. And so that sort of warming of 1 to 2 degrees across the UK, for example, is almost inevitable now. Whether we end up at 4 or 5 or 6 is still very much in our control.
The idea that the way the climate will change over the coming years is up to us is a sobering thought. We know that human activity on a large scale, massive deforestation, the near universal use of fossil fuels is changing the climate. But can anything that you or I do individually, can that have an effect? Well, over half the carbon dioxide produced by mankind comes from our domestic activities. Meet the Carbons. They're a fictional family living somewhere in the Western world. They occupy an average suburban house outside an average city. The Carbons depend on an average amount of electric power. It comes to them by an energy grid powered primarily by fossil fuels, coal, oil and natural gas. The Carbons are not bad people.
Girls, you want coffee pancakes?
But as Westerners, they have one of the most energy-hungry lifestyles on the planet.
Girls?
What's for breakfast? Yeah.
Pancakes, daddy cakes.
Which one, pancake?
I'll call you from the airport. Bye.
Bye.
Mr. Carbon's car, like most, spews out a lot of carbon dioxide. And the Carbon family has 2 cars. Every year between them, they pump a staggering 20 tons of carbon dioxide into the atmosphere. 10 tons per car. But it's not just the cars. Running the Carbons family home with all its comforts uses almost as much energy as their vehicles do. Every device, functional or fun, has a knock-on effect. At the power plant. Scientists fear that at this rate, these everyday emissions could, within 50 years, push our climate to a critical point where change is no longer gradual, but sudden and extreme. In the Arctic, thousands of miles away from the carbon's home, the ice is already melting.
The losses of sea ice have really just astounded us. It's one of the most marked and pervasive changes we've seen in the Arctic system, and it has really opened our eyes. If we compare the amount of Arctic sea ice we had back in about 1979 compared to what we have today, we've lost an area roughly twice the size of the state of Texas in 20 short years. This is really a remarkable pace of change that we've seen.
Twice the size of Texas is over 5 times the size of the United Kingdom. And it's not just the Arctic. In 2002, at the other end of the world, Antarctica's entire Larsen B ice shelf disintegrated. When white ice is replaced by dark ocean, it's the beginning of a sudden major change, a tipping point where the warming accelerates dramatically.
The sea ice cover is so bright and white that it reflects so much of the sun's energy that falls on it right back up into space. But if we start to warm up the Arctic and we start to melt down that ice cover, what we do is we start to expose dark surfaces, dark ocean. And that dark ocean absorbs so much more of the sun's energy than the white ice did that the Arctic further heats up, which implies further melt of the snow and ice cover and even further warming.
Some predict that the summertime Arctic could be completely ice-free as soon as 2070, and all that dark ocean will warm the planet even more.
We are, in fact, conducting a grand global experiment, and we're going to have to live with the outcome of that experiment.
I don't know what human beings will react to that, but obviously the natural world will have great difficulty indeed in migrating to keep pace with that over a century.
That's absolutely right, and that's one of the biggest concerns.
It's happening now, of course, isn't it? I mean, Mediterranean species are coming into Britain.
Yes.
But the ones at the very top, in the Arctic, they've got nowhere to go.
That's right. And that's also true with species migrating up mountains, of course. So that's where you'd expect to see the impacts first. And I think there's already evidence of that occurring.
On mountains?
Yeah, of mountain species changing.
And presumably a great number of those plants, species of plants and animals, will disappear.
That's the worry, yeah. The planet will change. I think whatever happens now, the planet is going to change. The question is, can we give it a soft landing?
No one knows for sure what impact global warming will have on the world's animals and plants. Some predict that by the end of the century, as many as half of the world's species could be under threat of extinction if their environment radically changes. Animals with a particularly specialized way of life, like South America's spectacled bear, are just one of hundreds of mountain species at risk as the Andes heat up. Southern Africa is predicted to be one of the worst affected areas. Here and elsewhere, animals will be forced to try and migrate en masse as their habitat is transformed. There will certainly be many casualties. There's no threat of extinction in the carbon's house. On the contrary, there is plenty of food here. Often it will have crossed continents by the time it reaches their kitchen. Transporting this food accounts for over 1/10 of the carbon's annual greenhouse emissions. And it doesn't end there. More carbon dioxide is produced by the carbon's rubbish. Buried in a landfill, the rubbish heats up as it decomposes, releasing greenhouse gases into the air. All the while, the carbon dioxide blanket surrounding the Earth is getting thicker, pushing the planet's ecosystems closer to the point of no return. Let's look at Amazonia.
Yeah.
What's happening now?
We believe that if these projections are right, then by the middle of this century, CO2 keeps going up, the forest could actually start to die from climate change, which would be absolutely catastrophic.
The Amazon rainforest is already suffering the devastating drought. In 2005, rivers ran dry. And scientists like Dan Nepstad have now discovered that the forest is facing a previously unimaginable threat.
For decades and decades, it was thought that these forests don't catch fire. And then some researchers started finding charcoal in the soil of forests deep in the Amazon of Venezuela. We had to alert the government that they had a major catastrophe on their hand, and the initial response was, no, it can't be. These forests won't catch fire. But more and more, as the droughts gets more and more severe, we see these forests being pushed over the edge.
Nepstad has already found evidence which points to a devastating future for the greatest forest on Earth.
For me, one of the scariest visions of the future of the Amazon is what we see back here. It's scrub forest that's very nasty to walk through. It keeps catching fire, it's highly flammable, and it's of very little worth to the local people.
But it's not just local people who will be affected. If all of the forest is destroyed, the carbon stored in the tissues of the trees, up to 15 years' worth of global emissions, will be released into the atmosphere, increasing the warming even more.
So that's one of these tipping points in the climate system where you could get to a carbon dioxide level where the forest is not sustainable, and that therefore means you get even more carbon dioxide and further climate change. It is a tipping point.
we won't just lose the most diverse ecosystem on Earth. We could also lose an irreplaceable mechanism for cooling the planet.
We almost might think of it as the world's great air conditioner. That is, it takes in all of this sunshine, and it converts about half of that sunshine into water vapor. And in doing that, it's cooling off the planet, and it's big enough to actually have an effect at the scale of the entire planet. The Amazon may not be here. It's frightening to me.
Mr. Carbon dreams of a tropical rainforest holiday, but today he's on a business trip. But when he flies, he's contributing to the fastest growing source of carbon dioxide. Even with plans for more efficient engines, emissions from aeroplanes worldwide are set to double in the next 25 years. Altogether, the Carbons are responsible for a whopping 45 tons of carbon dioxide a year. In cities all over the developed world, millions of ordinary households produce great quantities of carbon dioxide simply by going about their daily lives. So far, it's the Western world which has produced the majority of the greenhouse gases. But that is set to change. Meet Mr. and Mrs. Tan. They are a fictional couple living in an average Chinese suburb. At present, they use only a seventh of the energy consumed by the Carbon family. But life for the Tans is changing fast. And they, together with 1.3 billion Chinese, are heading for a more energy-intensive lifestyle. Mr. Tan has got a new job, and it comes with a flat in the latest upmarket development, complete with state-of-the-art, energy-hungry fittings. To fuel their economic boom, China has one main cheap source of energy: coal. Coal is the most carbon dioxide polluting source of energy we have. Currently, China is planning to build a large coal-fired power plant every week for the next 7 years. In as little as 20 years, China is likely to become the world's #1 greenhouse gas emitter. There is an explosion in energy consumption worldwide, And by 2050, we're on course to have doubled the amount we emit. All the carbon dioxide we produce doesn't stay forever in the atmosphere. It's continually being absorbed by the world's oceans. As the concentration in the atmosphere rises, so the oceans take up more. And this could lead to another of those tipping points. Marine biologists like Steve Widdicombe are now becoming concerned about the impact this is having.
Now that carbon dioxide does not stay up in the atmosphere. Almost half of it is dissolving into the oceans. The result of that is that our surface oceans are becoming more acidic.
When carbon dioxide dissolves in water, it raises the acidity. And that could be lethal for many of today's sea creatures.
If you look under here, what we have here is an animal that's very common to our shores, a beautiful animal. This is a sea urchin. This poor creature is going to be hit in two ways. Firstly, the acidity of the ocean will mean that its shell will dissolve, and secondly, the chemicals it requires to build that shell are going to be in short supply. Here we have another animal which is actually closely related to the sea urchin. This is the spiny starfish, and the kind of effects that could have on animals such as the starfish and the sea urchin could be that the animals have difficulty in creating their skeletons. They will also have difficulty in feeding, in reproducing.
Acidification poses a threat not only to individual species, but to an entire food chain. Plankton are floating plants and animals, some of which are microscopic in size. But they're so numerous that when they bloom, they can be seen from space. Acidification could decimate plankton, which is food for a variety of fish. And they, in turn, are food for larger and larger marine species. This could even affect the largest mammals on Earth. The effects of acidification could be felt far beyond the oceans. Millions of people around the world rely on marine life for their survival.
I mean, this is almost like a warning. This is what happens if we don't mend our ways as a species. We have a lot of choice. Humankind has a lot of choice over where we end up by the end of the century, because it's very much dependent on how much CO2 we emit between now and the end of the century.
So how do we cut down our carbon dioxide emissions? Some of the world's leading scientists are convinced that finding a solution is a matter of extreme urgency. Professor Steve Pacala is one of them.
I've worked on a variety of environmental problems in my lifetime, and usually you go into them and become a little bit less concerned as you go along. The global warming problem is the reverse. The people who are professionals and work on it become more and more concerned through time. For me, this is the most serious of environmental problems, and it's the one that we need to solve now. If this is the amount of greenhouse gas that we emit into the atmosphere every year today, then 50 years from now, we're going to be pumping out twice that much. And to solve the problem of global warming and to prevent the atmospheric blanket from more than doubling, what we need to do instead is to freeze emissions at the current level for the next 50 years.
Because there's no single way to solve the problem of global warming, Pacala has broken it into 7 equal pieces. He's then suggested a different way we can solve each slice, one at a time, until we reach the ultimate goal of halting the rise of carbon emissions.
I've looked at it closely, and I believe that it can be solved by this generation. The technology now exists to solve the greenhouse warming problem if we develop the collective will to implement it.
The first of Steve Bacala's slices can be dealt with using technology close at hand. I met carbon counting guru Dave Ray to find out how we can all set our house in order. Okay, so here is a newly built house.
This is where really climate change begins. Our houses represent a huge amount of emissions. On a household basis in the UK, each household emits about 25 tonnes of greenhouse gas every year. So they're a huge contributor to our climate impact.
Let's have a look inside.
So this is a prime example of a lot of energy use going on in the home and actually a lot of wastage.
What, this thermostat?
Absolutely, yeah. And this one's set too high. For every degree we reduce it, we'll save about 1/3 of a tonne of greenhouse gas.
Every year?
Every year.
So that comes down?
Yeah.
And I wear a jersey?
Yeah. Dress for the weather is the bottom line.
So the Carbons, bundled up for the winter, have turned their thermostat down 3 degrees. It saves them money on their electricity bill, and each year it keeps a tonne of carbon out of the atmosphere. Television.
Yeah, this is a big one. Now, if we look at some of these gadgets down here, we've got lots of little lights. They're using energy even when you're not watching television, and together in the average home they're now accounting for about 10% of our electricity use. All these things on standby power. So they're draining electricity from the grid.
10% of all household
Electricity, yeah.
Goes on complete waste, simply standing by.
It's basically electricity just to power little lights.
I have to say I had no idea it was as high as that.
The rule of thumb is, if you finish using something, then turn it off.
It isn't that turning on and off a set damages it?
Well, if there is, then the manufacturers have a real problem that they need to sort out.
There are dozens of things we can do around the house, from composting vegetable waste to switching to energy-saving light bulbs. So that really will help preserve the Arctic ice cap, just by changing a bulb?
It'll do a tiny bit in the right direction. This is good news for this house because it's a gas hob rather than an electric one.
The more insulation, the better.
For an average fridge, you can save 200 kilograms of greenhouse gas just by keeping the thing clean.
And buying locally grown food can cut down on the food miles.
And they're grown right here. That's pretty cool.
If we all made the most efficient choices in our homes and offices, we would reduce those emissions by 1/4 and cut off one of Steve Bacala's global warming slices. Perhaps the simplest way most of us can combat global warming is to change the way we drive. The Carbons have opted for a more fuel-efficient car. If by mid-century 2 billion of the world's cars can do 60 miles to the gallon, it would deal with one more of the 7 slices. Or if we all drive half as much as we do now, which might mean using public transport instead, we will also plus a slice. Another major challenge is to find carbon-free sources of power. However controversial, tripling the world's nuclear power would cut our emissions by a further slice. This is a solar farm, 3 acres of solar panels dedicated to collecting energy directly from the sun.
Renewable sources of energy, such as solar panels, are able to produce electricity with no carbon dioxide emissions to the atmosphere at all. And these might be scaled up to provide a sizable fraction of the solution to the global warming problem.
In countries like China, solar is set to make a real difference. Britain's climate, however, has never been perfect for solar power, but there are other natural resources we have plenty of. Our country is the windiest place in Europe. It's impossible to comprehend the sheer size of these towers unless you get really close to them as I am now. There's nothing to give you scale, but they are immense. The diameter of the rotor is 90 meters. That's almost as long as a football pitch. And to my eyes, they're beautiful. What's best about them is that once running, they don't give off carbon dioxide. But they're not cheap. And worldwide, we would need 700,000 more turbines like these to cut another slice off global emissions. That's a very big wind farm. Of course, wind farms are only one of a number of potential sources of new energy. And it's quite clear that if we're really going to tackle climate change, we have to think even bigger. Steve Pacala believes strongly that the technology we already have can save us. He's on his way to visit one of the newest techniques, and they don't get much bigger than this. "200 kilometers off Norway's coast lies the Sleipner gas rig.
This is one of the largest objects ever lifted by people, and it's sitting here on the sea floor for the sole purpose of keeping harm out of the atmosphere.
The people who extract fossil fuels like oil and gas have now come up with a way to put carbon dioxide back underground. Already, every year, 1 million tons of carbon dioxide are being pumped down into the rocks hundreds of meters below the seabed. The Norwegians have estimated that we could store all of Europe's carbon dioxide emissions for the next few hundred years in this way. But we would need several thousand of these rigs around the world to get another slice closer to the solution.
This isn't a magic bullet. This is maybe 15% of the solution for the next generation or so. What really has me worried is the number of things that we don't yet fully understand that I call monsters behind the door. This is exactly the kind of technology that could keep those monsters from ever coming out from behind their doors. It's going to give us an additional bridge to the future for our children and their children and their children. This is our watch, and we have to get it started so that we can leave them with a world in which the monsters are still behind the doors.
Already, change is in the air. And people all over the world are waking up to the urgent need to deal with global warming. Expanding economies like China are developing new technologies to combat increasing emissions and are encouraging the people to get involved in tree planting. The task ahead of us is vast, but we can all make a difference at every level, even the smallest. All right, well now let's get this clear. It's not about stopping making ourselves cups of tea. We're talking about living the life more or less as we've lived it before, but more efficiently.
Yeah.
Waste is the source of the trouble, not actually living.
No.
Please make me a cup of tea.
Certainly will. So the first thing I'm going to do is, we don't fill it with water, obviously, we just need water for 2 mugs. It doesn't matter which nation it is, it's important.
Don't waste it. Now, to make a good cup of tea, you've got to make it while it's hot.
Yeah.
You didn't warm the pot.
I didn't warm the pot, no.
Oh well, we'll see what the quality of the tea's like.
Cheers. Any good?
Rotten. As we travel into the future, it's clear that there are some steps that we can take, both big and small, to reduce carbon emissions. But because we're talking about the future, we can't be sure where we're going. But one thing is certain, if we do nothing, we'll end up in deep water. If we continue to warm our planet, we may accelerate the meltdown of the world's ice, resulting in a catastrophic rise in sea level. Recent satellite evidence has revealed that not only is the Greenland ice cap melting, it's doing so twice as fast as previously thought. Scientists now fear that we are approaching the tipping point, where the complete meltdown of Greenland's ice is inevitable. If it does melt, it will cause sea levels to rise by as much as 7 meters. This may take centuries, but it should surely concern us all that our actions today could condemn the future world to disaster. The combination of melting ice and warming waters will expand the seas, and this could raise their level by ½ meter before the century is out. When you remember that half of humanity inhabits the coastal zones around the world, sea level rise is a frightening prospect. The islands of the United Kingdom are not immune. If the Greenland ice melts, the sea will flood much of the southeast, including central London. In fact, many of the world's most famous cities would be engulfed by the ocean. It would take far less to drown much of Florida. With just a 5-meter rise, much of the state would be submerged, and the city of Miami would be 50 miles offshore. The same rise would wipe half of Bangladesh, home to 120 million people, almost entirely off the map. Millions of people would be displaced. Worldwide, scientists predict that global warming could displace 150 million people within 50 years. You spend your working life pondering on this kind of change and this kind of effect. Doesn't it depress you deeply? How do you get up in the morning and survive?
It is. I mean, I think if you see it as a foregone conclusion, you can't help but be depressed by the prospect. But I don't. All climate modelers would like to be wrong. So when I look at these, if I just believed that was an inevitability, I would undoubtedly be very depressed. Not necessarily for myself, because in the next decade or so, we can probably deal with it. But certainly for my kids and ultimately for my grandchildren, it would be an extremely depressing prospect. But I still think we can do something about it. That's the big challenge now, is to get some action on behalf of future generations to avoid some of these worst impacts.
I must say, I think if you had to look in your grandchildren's eyes and say, yeah, I knew that it was going to happen, but I didn't bother to do anything about it, that would be a terrible thing.
Well, wouldn't that be the worst thing of all for any generation, to say left something like that for future generations to pick up, and we knew about it, we knew about the problem, but we didn't deal with it? That would be the worst thing of all. No, we have to avoid that.
Exactly so. In the past, we didn't understand the effect of our actions. Unknowingly, we sowed the wind, and now, literally, we are reaping the whirlwind. But we no longer have that excuse. Now we do recognise the consequences of our behaviour. Now, surely, we must act to reform it, individually and collectively, nationally and internationally, before we doom future generations to catastrophe. For a free guide about climate change and more about Open University programmes, call 0870 942 1342 or go to bbc.co.uk/climatechaos.